We're talking about inequalities. We're getting ready for that quiz. Quiz is on Wednesday. And this is a word problem. The first thing I want you to do is just label the sides of that rectangle. By now you should be good at that. We've practiced that a lot. If one side's x, the other side's got to be what? Not 50 minus x. That'd be if it was perimeter. For area, what do you think? 50 over x. How would you know you were right? Because you would test it and go x times 50 over x, which is also known as the length times the width, would equal 50. So x times 50 over x, see how the x's cancel and it equals 50, just like we want? All right. Another way to say this is, if you don't know how to do those, if you're like, I still don't get how to get these, then write the formula for it. Right, area equals length times width. Then we know the area, 50 equals length times width. And then we know one of the sides, either the length or the width. I'm going to call it the length is x. And then I just solve for w. Well, the other side must be 50 divided by x on both sides. W is equal to 50 over x. Now I know what to put here. Okay? So there's a couple ways you could do that. Now that we know that, you're going to need to use a different formula to answer this question. If the x minimum is 1, what is the maximum perimeter? All right. So then, as soon as I said perimeter, you should be thinking, oh, I got a formula for that. Write it down. If you don't have it memorized, memorize it now. Perimeter is 2 lengths plus 2 widths. And now I don't know the perimeter, so I can't put anything for p. I know the length, though. What's the length? X. What's the width? That 50 over x. Could I make that 100 over x? Sure I could. And then put it into your calculator, because you'll have to do a minimum or a maximum. Anytime you're doing either one, you want the calculator involved. All right, so grab your calculator, type that puppy in. If you need to borrow one of mine, do it fast, please. Okay, once you get yours graphed, I know it won't look as nice and pretty as mine, but go to your window, think about it. Your x is your side of your shape. In fact, I have from 0, but really x minimum, it says right on there, it says on the problem that x minimum is 1, so I could put a 1 on here, but then it's kind of sometimes hard to read, but I'll put a 1 there, that's fine. X maximum. Do I know my x maximum, the length of a side? Well, I know the total is like 50, so like, I don't know, I suppose I could have one side be 1 and one side be 50. So I'm going to put my x max as, I don't know, 60. The point is you don't have to know exactly, but you're going to get close. Now what are these y's? That's this part right here. That's the y. The y is the perimeter. So we want the perimeter. So what is the perimeter? Well, I don't know, if the area was 50 and it was like a 5 and a 10 for the sides, or even a 50 and a 1, so I don't know, 100 is max, maybe something like that. So 0, because you can't have a negative perimeter, of course, and make this like 100. So just think them through, graph it, and you see how it's got a low spot? If they'd asked me for the minimum, I'd be all over it. I'd just find that low spot and be done. Did not ask you for a minimum. What does it ask for? The maximum. Well, and you got to know what the perimeter is. The perimeter is y. So I want the highest that this graph ever is. But wait a minute, it could go forever to the left or forever to the right. So how do I know what the highest spot is? Well, it really can't go forever to the left. What's the farthest left that it could go? Where x is equal to what? 1. Where x is equal to 1. That's the farthest left we can go. We can't go to x equals 0 or x equals negative things. So x equals 1 is like right along in here and following it up to like right in there maybe. Or, now we got to go back to our picture and just think for a second. If x was 1, If x was 1 and the area has to be 50, thank you very much, sir. You can sit on this. Appreciate it. If the side's 1 and the area's got to be 50, that's got to be 50. You get that? If the area's got to be 50 and one of the sides is 1, 1 times 50 makes 50. So the biggest it could be is 50. So if you go back to your picture here and you either say x is 1 or you could say x is 50, either one. One of the sides is 1 and one of the sides is 50. That's where you're going to get your maximum perimeter. So if I go to x equals 1 and figure out what the perimeter is, do I even need the graph anymore? If I know that one of the sides is 1, can't I tell what the perimeter is? Pretty easy. Yeah, it's got to be 1 with a 50, and this has to be 1, and this has to be 50. So what's the perimeter? 102. Otherwise, if you want to do it a neato techie way, I could say, go to second, calculate. I just did something wrong. There we go, calculate. The value, the very top one. Everybody do this on your calculator right now. It's really good skill to know. And then see how it brings up an x equals blinky? What do we want x to equal? Either 1 or 50. Let's try 1. What's y? 102. See how I could have got the answer that way? Otherwise, I could just think it through on my piece of paper and say, well, if one of the sides is 1, then the other side's got to be 50, and then its perimeter is going to be 50 plus 1 plus 1, which would be 102. That works also. Either way, the answer is 102. Now, what's the other thing it could have been? If x wasn't 1, x could be 50. Go to calculate. I keep on doing this in the wrong order. Quit out of that. Calculate. What? I swear I have hit second. Oh, I'm hitting the y equals, not that. There we go. Go to value again. And this time type in x equals 50. Take a wild guess what it's going to be for a perimeter. It's going to be 102 again. Okay, so if I go way to the right, it's still going to be up as high as 102. So either way, my answer is 102. Remember, it asked for the perimeter. It didn't ask to tell me that the side was 1 and 50. It asked for the perimeter, which is 102. Remember to check your answer. Make sure you gave them the answer they wanted. It's painful to go through the whole problem, get an answer that takes you a lot of work, and then you give them the wrong thing. All right, moving on. This one. If I multiplied by x minus 1, it would fix one problem. If I multiplied by x plus 1, it would fix a different problem. But if I multiply by both, it'll fix everything. Go ahead and do it. When you're all done, don't use the quadratic formula. Just remember what it is, because we'll do the quadratic formula on the next problem. This one's numbers are pretty ugly, so the quadratic formula doesn't work real nice. You need to put one of those here and here and here. And multiply it all out. This is why this is one of the harder tests, because there's so much little grinded out kind of stuff. It's not super hard. After this cancels this, then I have x squared minus x. And then after that cancels that, I have 4x plus 4. And then this part right there is first outside, inside, last. X squared, the outside and the inside would cancel. Minus 1, x squared minus 1. And I times it by 7, so I get 7x squared. That was 7 times x squared minus 1 like this. And then 7 times the negative 1 makes minus 7. The grinding it out, sometimes something that kids aren't very good at. Move that over there. Put this and this together. This is kind of dangerous. I'm trying 2 steps at once. Almost always screw that up. But I'm being really careful. Equals, and I'm taking away an x squared, so it's become 6x squared. There we go. Now I'm going to move more stuff over there. Get that over there. 4 equals 6x squared minus 3x minus 7. Then get the 4 over there. 0 equals x 6x squared minus 3x minus 11. Raise your hand if you got the same thing as I did. Good, then you can grind it out. That's what's going to take on these. It's algebraic manipulations, the topic of the test, so you got to be able to handle that. It's not incredibly hard, just got to be detail-oriented and careful. All right, what if we had to use the quadratic formula? This one works out nice on the quadratic formula. Would you please stretch your brain, make sure you remember how to do that, because what if it won't factor? And what if you don't have a graphing calculator? That's a recipe for got to use quadratic. I never try to do the whole square root in my head. I hope you don't either. Because you're really likely to screw it up because there's multiple signs, there's 4 numbers that have to get squared and multiplied, and then you got to put it all together, and you're really likely to screw it up. So then go back and put in A and C, and now look what's underneath the root. Do you get how there's 2 negatives under there, so it turns into a plus? 9 plus 8 times 5 is 40. 9 plus 40 is 49 underneath the root. Now it's going to be easy. Negative 3 plus or minus, and if it's a square root of 49, it's really 7 over 4. And then your final answer, put that negative, do it once with plus and once with minus. You get 4 over 4. And you get negative 10 over 4. And this one comes out to 1. And this one comes out to negative 5/4, which would be also known, yeah, let's just call it, or negative 5 seconds, sorry, also known as negative 2.5. There are my 2 answers. Why did I just get the problem wrong? Yes, you double check for extraneous. Now, in this case, they both do work. But I'm telling you, you're going to have to check that. You only have 8 questions on your test, right? Well, it's not counting the R4. Some of you guys are getting pretty good at those, so maybe you'll have 9 questions. But of the 8 questions, only the R3s are really, really important. So you got 4 questions you should double check your answers on. It's very reasonable to do that. When your homework, like today, you get this giant packet, a whole bunch of stuff to do between now and Wednesday. I wouldn't be double checking every single answer because it would take too long. But on a test, definitely check them. Because here's what could happen. In this one, they both happen to work. But what if it was in one of those problems where it's like over x minus 1? Then one of my answers, which was 1, would have crashed this. Because as soon as you put in x equals 1 right here, it would make the denominator 0, and then it would be, that doesn't work, x is an extraneous answer. If that ever happens, take it and go extraneous. Again, in this case, it was not extraneous. I'm just showing you if you had checked it and it hadn't worked, that's what you do. All right, acid problem. See if you can do this one. Looks similar to other problems we've done, but it is different. Still use that same formula, though. I'll pause while you work on that. Here is that formula in case you've forgotten. Amount 1, percent 1, plus amount 2, percent 2, equals amount 1 plus amount 2 times the total percent. This formula works really well for solving any mixture. It could be a mixture of your first quarter and second quarter grades. It could be mixing, well, I don't know, something that has 1% and another percent. Like maybe one kid's shooting 85% free throws, another kid's shooting 60% free throws, and they're both going to be shooting free throws, something like that. Amount 1, I don't know, but it's 72% acid. Plus amount 2, I do know, 5 times 0.84. Equals amount 1, n, amount 2, 5. Total percent, it says 79%. Again, grind it out. I'm going to save some time here, jump right to the answer. But I can't remember what it was. It was like 4 or 5, something like that. Who's got it? Is it 5 point something? Just 5? Is it rounded exactly 5? Okay. Does anybody have an answer that's close to 5 that was more not rounded? So I could have swore I did it last hour and it was 4.8 or something like that. You sure it's 5? Exactly? 4.3, we got a 5. There's two smart kids getting different answers. That's curious. Maybe neither one of them's right. All right, so take some time, grind it out. I will too. How about this? Mr. W, could you do the 5 times 0.84 for me? Thank you. And then 0.79 and plus. And how about the 5 times 0.79? Thank you. Then I got variables on both sides. Get rid of the smaller one. All right. 4.2 equals 0.07n plus 3.95. Divide both sides, subtract 3.95 from both sides. That'd be a really easy mistake place right there. I'm guessing some probably messed this up. I'm going to put an extra 0 there to hold that place, to be careful. And this would be 0.25 left. And I bet that's where the mistake was made. And then final answer is take 0.25 divided by 0.07. Can somebody verify what that is? What? 3.57. Thank you. 3.57. Interesting. Two smart kids, neither one of them had exactly the right answer, but maybe it's just a rounding issue. I don't know. It was kind of, one was a little too low, one was a little too high. So average them out and they were perfect. All right. Any questions on that? Now, that scares me just a little bit because you're a lot of smart kids, and two of the kids that oftentimes get the 4s right on the test both got this wrong. So be careful. It's just about grinding it out from there. Is there any part of this that you want to ask me about that you weren't sure how it worked? Because just because you know the formula, it does not mean it's a lock you're going to get the right answer. We just evidenced that. Is there any part of this you want explanation? Because I can explain it. Okay. All right, moving on then. This one, let's just jump right to the sign chart because this will be super simple. There's 3 things on the sign chart, -1 and 5 and 9. Those are called the zeros. They're the x-intercepts is also the same thing as a 0, right? And if they're a 0, this whole thing becomes 0. Is 0 greater than 0? 0 is not greater than 0, so none of them work. And now, just test your intervals and see what the final answer is. Okay, I'm just going to test one thing to show you how it's done. Let's say I wanted to test something between here and here, like 0 would be in there. If I tested 0, I put in a 0 here and here and here. Then I have 3 things to say whether they're positive or negative. The first one is 0 minus 9, so it's negative. The second one gets squared, so I don't even have to look. It's positive. It has to be positive. Get that? This one, since it's squared here, it's guaranteed locked that it's got to be positive. And then x minus 5, I've put in a 0, it's going to be negative. 2 negatives and a positive makes a positive. All right, so help me out. If I read from left to right, it's something, and then positive, and then something, then something. Mr. J. Anybody agree with him? Final answer then should be from 5 to 9, like that? Oh, because I'm looking for where it's greater than 0. I just found where it was less than 0. So actually, can I just say from negative infinity to 5? Yes or no? No, because there's an empty spot in the middle of that. So I'd have to say from negative infinity to -1, and then union with, then start over again and go from here to here, which would be -1 to 5, and then start over again and go from there, union with 9 to infinity. Okay, so it's a 3-part answer that time. Any questions on that? Okay, moving on. This kind, hopefully these are easy. You just do the top, do the bottom. That's going to be a negative 2. That's the x-intercept. That's going to be a negative 1. And that's going to be a 3. And then I just, each of those spots, what do I know about the bottom two? Automatically don't work because they're asymptotes. How about this top one? That one I got to check here. Because if I put in negative 2, it'll make it 0. Is 0 less than 0? No. Then I check between them, and it's easy from there. All right, this one I have done wrong twice. I'm going to tell you what I was doing wrong. I was saying to just multiply this by x minus 9. It's a really easy mistake to make. You know why you cannot do this? Because, do you remember if you ever multiplied by a negative, you got to switch the sign? When I multiply by an x, can I tell if I'm multiplying by a negative or not? I might be. And therefore, you're not allowed to do that. So that's why on the key, the teacher who was doing this was thinking about that, and I wasn't. That's why they were doing something weird over here, and they weren't doing anything to that over there. Because you're not allowed to multiply through by a variable. If you multiply through by a negative, that's okay. You switch the sign. You multiply by a positive, that's okay. But you can't multiply by x. All right, so how am I going to do this if I can't multiply that by x? I got to add these two together with a common denominator. Do you remember finding common denominators at the beginning of the year? This one has a denominator of 1. This one has a denominator of x minus 9. What if they both had a denominator of x minus 9? Would that be nice? Yes, it would. So how do I get this to have an x minus 9 down there? Only if I do the same thing where? On the top. Because then I have multiplied it by x minus 9 over x minus 9, which is really equal to 1. You can multiply anything by 1. You don't have to do it through the whole equation either. You just do the one thing, times it by 1. You really didn't change its value, but you changed how it looks. Okay, so now I have 2 over x minus 9 plus x times the x times the negative 9 makes x squared minus 9x all over x minus 9. Do they have a common denominator now? Yes, they do. And now they can be added together. The tops add together. The bottom stays the same. Final answer, x squared minus 9x plus 2 all over x minus 9. And it's still less than or equal to 0. Now it's a new problem, and now it looks just like this one. Except that hasn't been factored. Get what I'm saying? So now you'd have to factor the top, and now you do it exactly like you do the other ones. All right, so I know you kind of glossed over some of that, so I want to have you try one now. Alignments of my board is off. Try this one. 5 over x plus 7, and then plus 8 is less than 0. You can't multiply by x plus 7 everywhere. Got to do the common denominator trick I just showed you. Just put that over 1. Now I'm going to skip a step, dangerous, but I'm going to put all that together on the top and make my bottom be x plus 7 because they have a common denominator. And now on the top I'd have 8 times x is 8x. 8 times the 7 is 56. 56 plus the 5 is 61. It's just less than 0. And now, what would make the top 0 for my number line sign chart thing? Well, I'd have to solve this and figure out what would make it 0. It's negative something. Negative 61/8 actually. And then what would make the bottom 0? Negative 7. I got to figure out which side that is. That's almost -8, so -7 would be like here. And then -7's an asymptote, so it would never work. And the top thing would make it 0, and 0 is not less than 0, so that doesn't work either. And then I could check my intervals and all that stuff. All right. Next one. This is a sign chart. You're looking for where it's less than or equal to 0. Works there. Works there. Write me an answer. Should be snap. All right, in the back row. -4, but yes. Good. Oh, I got somebody. Because you forgot something. Aha! It's real easy to forget that, isn't it? That 3 works. And I was misleading because I only circled those 2 and I thought somebody'd fall into my web. All right. Union with 7 to infinity. Sorry, but somebody had to fall into the web to make the point. Okay? Even more ironic if it had been you. Okay. Falling into the web. This one just tells us we have 2 worksheets, and they're due Wednesday, and the quiz is Wednesday. So here's the worksheets. Oh, where are they? Here's the worksheets. I'm about to hand them out. You have a bunch of time to work. And hopefully you've learned something over the last week. Get more time to practice this than any other test. It does not guarantee you're going to do well on it, but at least you've had lots of time to practice. So